Right, year 12, I'm going to go over a couple more of these questions from exercise 10.1. Remember that we're using our knowledge of NCR, which equals NR, which equals N factorial over N minus R factorial. So I want to do some of the ones here, question 9 and 10, and see how you go with those. So question 9, this is a bit of a doozy actually. Let's have a look at it. I've got to solve 20C2 equals 19CK plus 19C7. Now I know you can do this with the calculator, but what I'm going to do is I'm going to work both. This is a solve, it's not a show, so I can work both sides of the equation. So on the left-hand side, I get 20 factorial over 20 minus 2 factorial, 2 factorial. And here I get 19 factorial over 19 minus k factorial, k factorial, and here I get 19 factorial, 19 minus 7 factorial, 7 factorial. So let's work this left-hand side. I'm going to take 20 out of that. Oh no, I'll just leave it alone for the meanwhile. So it gives me 18 factorial, 2 factorial. Sorry, it's 20C7. Let's just tidy that up. So this is all 7. 20 minus 7 factorial, 7 factorial, which gives me 13 factorial and 7 factorial. Over here, I'm not going to touch this. I'm going to leave that alone, 19 minus k factorial, k factorial. And here I'm going to get 19 factorial, and I'm going to get 12 factorial, 7 factorial. Now this is a solve and I've just got to find k, so I'm going to take all of this bit and subtract it. So I get 20 factorial, 13 factorial, that's going to be too big, over 13 factorial, 7 factorial, minus 19 factorial, 12 factorial, 7 factorial equals 19 factorial over 19 minus k factorial, k factorial. Now I know you can play with your calculator and work this out, but the object is not to do that. The object is to play with the factorials and see if you can get it. So this 20 factorial, I'm going to write that as 20 times 19 factorial. I'm going to take that 20 out. And I'm also going to take 13 out of this. We'll put the 13 there. There's a multiplication there. And if I take 13 out of that, I get 12 factorial, 7 factorial, minus, now I'm going to write something in here. Check this out. I've got one of these. One. I've got one 19 factorial, 12 factorial, 7 factorial. And now I've got the same thing. I've got 20 on 13 of this stuff minus 1 of this stuff. And over here, I've still got my 19 factorial, 19 minus k factorial, k factorial. So here I'll take the 19 factorial, 12 factorial, 7 factorial out, and I've got 20 on 3 minus 1. But 1 is 13 on 13. Right? 1 is 13 on 13. I'm doing a subtraction here, could have done it on my calculator. Still got my 19 factorial, 19 minus k factorial, k factorial. So I've got my 19 factorial, 12 factorial, 7 factorial, and remember this is multiplied, I factorise that. Well, 20 minus 13, I'm going to get 7, and that's a 13. 7 on 13. equals 19 factorial on 19 minus k factorial k factorial. Now, 19 factorial, 12 factorial, 7 times 6 factorial. I'm writing that bit like that because I'm going to cancel the 7s. And now I can put this 13 in here. So I get 19 factorial on 13 factorial, because 12 factorial times 13 is 13 factorial times 6 factorial. And again, I'm just going to bring that down here. And eventually, I get 19 factorial on 19 minus 6 factorial, 6 factorial, and that's got to equal 19 factorial on 19 minus k factorial, and therefore k equals 6. Once we've got it in exactly the same form. So that was a bit complicated. And if you're able to do that one, you're looking pretty good. Now, let's have a go at some of the ones in 10, because some students were having issues with that. So I did 10A on the board, but I'm going to do it again here. And I'll do a couple of others and then see how you go. So 10A, I've got k factorial plus k plus 1 factorial. Now here are some things you need to know. You need to know that k plus 1 factorial is the same as k plus 1 times k factorial. It's the same as going, well, 7 factorial equals 7 times 6 factorial. And the other thing you need to know is k factorial can be written as k times k minus 1 factorial. So if you've got that 6 factorial, it's the same as 6 times 1 less factorial. And that's what I'm going to do here. So I've got my k factorial. I'm going to write this as k plus 1 times k factorial. I'm going to factorise out my k factorial. And here I'll be left with 1. And here I'll be left with k plus 1. And that'll give me k factorial. And 1 plus 1 is 2, so I get k plus 2, which is what we're looking for. I'll just check the answers, which I've got sitting here. Question 10. K plus 2 times k factorial. Let's have a go at, I'll let you do B. C, I'm going to have a go at D. So 10D. Because this one uses a k minus 1. So I've got k minus 1 factorial plus k plus 1 factorial. So we need to get some common ground. So remember, k minus 1, I can write that as, I'll just leave that as k minus 1 factorial. And plus, well, k plus 1, k, and k minus 1 factorial. I'll take out the k minus 1 factorial, and I'm left here with 1 plus k plus 1 times k. That'll give me k minus 1 factorial, and here I get 1, and I just do this little expansion here, k and 1, which will give me k squared plus k. That's a quadratic, k minus 1 factorial, and that's k squared plus k plus 1, which is the answer. Let's have a look at another one. And I'm trying to find one that has a negative. Let's go 10f. And what have I got? T factorial plus t plus 1 factorial. Let's just double check that that is a question. Oh, minus t minus 1 factorial. Minus t minus 1 factorial. Well, let's see what we can get out of here. I think I'm going to need to get the lowest one, which is a t minus 1. So I'm going to try and write them all as something times t minus 1. Well, t factorial is t times t minus 1 factorial. Just take one off. T plus 1 factorial, well, that's t plus 1 times t minus 1 factorial. So write the first three terms. And I'll just leave that last one alone, t minus 1 factorial. I'll take the t minus 1 and factorise it out. It's in each of them, t minus 1 factorial. So I get t minus 1 factorial, and what am I left with inside? On the first one, I've got a t. Here, I've got a t times t plus 1. And I've got that just one thing there at the back. It's pretty easy to forget that. So t minus 1 factorial. I'll have a t. I'll quickly expand this and get a t squared plus a t. So a t squared plus a t minus a 1. Let's tidy that up, collect the like terms. T minus 1 factorial, and I get t squared plus 2t minus 1. And that's the answer. All right. Question 11, again, is similar. I'll do 11a and 11e. So 11a, I've got k minus 1 factorial over k factorial. Well, k minus 1, I'm going to leave that alone, but this k factorial I'm going to write as k times k minus 1 factorial, and I'm going to cancel those. Please don't be left with 0 on top. There's 1 on top and k on the bottom. Pretty easy. Let's go down to E, 11e, and I've got k minus 1 factorial on k plus 2 factorial. Now this is going to be hard because I'm going to have to reduce that k plus 2. I'm going to have to get 4 terms to get rid of the factorial. So k minus 1 factorial on the bottom. I'm going to start with k plus 2. I'm going to go down the next one, k plus 1. Then I'm going to go to the k. And then I'm going to go to the k minus 1 factorial. My k minus 1 factorial is going to cancel. On the top, I get 1. Underneath, I'm going to get this big cubic. I'm going to get k plus 2, k plus 1, k. Now, in the answers, that's how she leaves it. I'm going to expand it. So I'm going to do the first one, and I get k times k is k squared. I'm going to get a 2k and a 1k, so I'm going to get a 3k, and I'm going to get a 2. And then I've got that k. I just quickly expanded that bit. Now I get 1 and I'll get a k cubed plus a 3k squared plus a 2k. Margaret leaves the answer like this, which is pretty good, factorised form. That's how we like to do those. Question 12, again, you can do those on your calculator. They're pretty easy. I'm going to leave those. And question 13 is pretty easy. I want to have a quick look at question 14 and 15. I'll do 14 and I'll leave 15 for you. I have done it, but I want to see if you can do it. So 14. Let's have a look at it. Simplify NCK and NCK minus 1. All right. So NCK on NCK minus 1. Well, NCK is n factorial over n minus 1, n minus k factorial, and then we've got n factorial over n minus k factorial, n minus k minus, I'll fix that up. N minus k minus 1 factorial times k minus 1 factorial. Now, I'm not going to even, I'll tidy that bottom bit up because that's going to become n minus k plus 1. That bit there is going to become n minus k, and minus 1 is plus 1. But I'm not going to touch the other bits because when I divide a fraction, I multiply by the reciprocal. So I'm just writing the top bit, so n minus k factorial k factorial. I'm multiplying by the reciprocal. So remember this top bit I said was n minus k plus 1 factorial and k minus 1 factorial and n factorial. Now, my n factorials are going to cancel. You're beauty. Let's just write this k factorial as something else. So I've got my 1 on the top. I'm going to leave this as n minus k factorial, but k I'm going to write as k times k minus 1 factorial. And as you can see up in the top line on the other side, I've already got a k minus 1. But this n minus k plus 1, so n minus k plus 1, well, if I go the next term down, if I take 1 off that, because that's factorial, that'll be n minus k factorial, and I've got a k minus 1 factorial, and remember, it's all over 1. Now let's cancel my k minus 1 factorial and my k minus 1, my n minus k factorial and my n minus k factorial. Right, now what have I got left? I've got n minus k plus 1 on the top, and on the bottom, I've got a k. And that's the answer. So being able to play with these and write them using the original definition is important. 15 requires a bit of work. I imagine that I'm going to have to do that in class with everyone there, but at least you can have a go with it, struggle with it. There is a work solution to 15 in the book, but you have a go at it yourself first.